right? So example 5, shown below is the graph of the derivative of f of some function capital F. Assume capital F of -3 is equal to -8. All right, that's going to be key. We want to start off with this right here, right? So what does this mean? They're telling us that this is going to be equal to -8, right? Well, what do we know of this function? We know that capital F is the integral, okay, of that function starting at some value of f of t dt. So they're already telling us, hey, when you start at -3, your answer is going to be equal to -8. That means the area of everything to the left is going to add up to a -8 value, okay? So to answer the question, what is capital F of 2? Well, we're trying to get to here, right? We're trying to get to here. So from -3, we're trying to get to 2. Well, to get f of 2, capital F of 2, we need to get the integral from -3 to 2, right? And we know that's going to be the area under the curve, but you can't forget the initial amount, okay? You cannot forget everything to the left of that. So in a way, you still need to get all of this, and we'll talk about that a little bit later, right? But if I get all the areas, all the area of the rectangles under this graph from -infinity to -3, they told us. They told us what it was. They told us it's going to be -8. So f capital of 2 is going to be our initial amount that they started us with, right? Plus whatever we get from -3 to 2. All right. So this is going to be 10 plus 26. That's 36. But don't forget that initial amount. Okay. And you end up getting 28. Cool. Again, if you don't get it the first time, just kind of think about it, right? Like they told us the area under the graph at -3 is the accumulation of everything before it, and it's gonna be a negative value. So we don't know what this graph does. We don't know what it does, but eventually it's gonna be a summation of negative, right? So there should be some negative areas or area under the x-axis. Okay, cool. We got the first one. So now how would we get capital F of 6? Well, we want to go all the way here, right? We want to get the area under all of this. And again, we have to start with our initial amount, okay? So capital F of 6 is going to be the initial amount that they started with, right? Plus the integral from -3 to 6. And again, we would just add all these areas. Starting with the initial amount, it would be -8 plus 10 plus 26. Now, what do we do with this value? Do you guys remember? Because it's under, right? We're going to consider it a negative area. So we're actually going to subtract it. Okay, I'll go ahead and give you guys a little bit of time to answer that question. And you should have gotten 34, okay? Okay, now the next one's a little bit weird, just because, again, they're asking this whole going back to the negative thing, right? So they're saying, let me clean this up a little bit. They're asking you to find capital F of -5. Where's -5? Well, capital F of -5 is right here, okay? Now, we don't know. We don't have any graph. We don't know what happens on this side. But they did tell us everything from -3 this way is accumulation of -8, right? Well, this plus this, they're telling us this, all this area, plus this is going to be equal to -8. So if we do that, you're kind of, again, working backwards. It's going to be the initial value minus the area to the left, right? So if we consider that, all of this area plus this is going to be -8. So in this case, you just end up subtracting the 18, and our area is going to be -26, all right? Just think about it a little bit. Maybe I'll repeat it one more time. So they want us to give to find capital F of -5, right? And we know that capital F of -3 is -8. So right here, all of this together is -8. Okay. But we want to find just this. Well, shouldn't we just subtract the 18, right? Just take it away because we want to find just the area from -5. So that's kind of how I consider, right? We have our initial amount, and they said, hey, you know what? Take away this area. Well, we know it's a positive area. So when we take it away, we end up getting -26. That means capital F of -5 should be accumulation of -26 in terms of area. Okay. That's kind of how I see it. If you're still struggling with it, just play it back, and maybe that would make sense to you. All right. Still in this example, they want us to answer a few more questions. Since the area under F is positive on the interval of -3 to -1, we know that the graph is going to be increasing, okay? We know that the graph is going to be increasing. Since the area of F is positive on the interval of -3, we know that the graph of capital F must be increasing. And again, use the idea that F, again, that we have the graph of the derivative of F, right? We have the graph of the derivative of F, okay, of some function, capital F. So I think that's going to be the key thing to think about in this case. So since the area under F is positive from the interval from -3, to -1, right here, they're going to tell us that the graph is going to be increasing, okay? Since the area under F accumulates at an increasing rate, okay, we know that the graph of F must be also concave up, okay? Must be concave up on that interval. Okay, the area under F on -1 to 2 accumulates, right? At a what? Let's see what's happening from -1 to 2. Yeah, we're still adding the area because it's positive, but you're adding less and less, right? So it's going to be at a decreasing rate. Okay. So again, F must be concave down. And at this point, you should be thinking about the second derivative, right? First derivative test and second derivative test. So how does the first derivative and second derivative, how are they in context of this graph, okay? And again, we're just looking at the slopes. So now we're going to sketch this graph using D, E, F. We're going to sketch it, but first, let's fill out this graph. Let's fill out this table here so we could get some points, okay? At -5, we said it was what? -26. At -3, they told us it was -8. We do not have -1, but we could figure it out, okay? What's going to be the value at -1? Well, if all of this was -8 to -1, from -3 to -1, that's 10. So the difference is going to be 2, okay? You guys see that? So we were not given this, but the total area accumulated when you get all the way to -1 is gonna be the initial amount, everything over here, which is added to -8, plus whatever area you get here. And since it's positive, you would add in, they told us that's 10. -8 plus 10 is 2. Okay, now if we go to 2, again, we already have the total area here is going to be 26, right? And we actually already solved that, so I don't have to go over that because that's A. Okay, if we go to 4, what happens at 4 though, right? What happens at 4? We have to subtract some area, right? It's just going to be the area from 2, all the area from 2, which is 28. But now we're going to subtract that negative area. So this is going to be 20, and the final one's going to be 34. So if we were to graph these points, just give me a second. I'll start graphing them. And again, you don't have to be that precise. Just kind of get the ballpark there. But the whole point is, by looking at the area under the curve, we could figure out what kind of function we're going to have, right? Thinking about it as the antiderivative. And I'm trying my best. It's a little hard to do on the tablet. Okay, that's not what I wanted. Why would it make that a straight line? There you go. So that's what we get from this graph. Again, so if we start analyzing the function here, right, we could start thinking about this function's derivative, right? It's concave down, it's decreasing, it's positive values. So again, just use the rules that you used from the last section on the first derivative and the second derivative and what they tell us about the graph. Okay.